Assalamualaikum warahmatullahi wabarakatuh and a very good morning. Today we are going to further our lessons on redox equilibrium with standard electrode potential. What is actually meant by electrode potential? The electrode potentials is a potential difference produced when an equilibrium is established between metal M and the aqueous solutions containing M plus ion in a half cells. We will see this example in the next slide. But for your information, in order to get the potential difference or electrode potential value, we need to ensure that the standard electrode potential, which also known as E0 of the cell, is measured at a standard condition, namely as the concentrations of the ions in the aqueous solutions is 1 mole per decimeter cube. If it is exists as gas, the gas pressure is at 1 atmosphere or 101 kilopascal. The third rule is the temperature when we do the experiment is at 25 degrees Celsius or 298 Kelvin. And the last rule is we have to use platinum as an inert electrode when a half cell is not a metal electrode. This is actually used in half cells of hydrogen. Okay, bear in mind that the electrode potential of an electrode system can be measured by pairing up the electrode to the standard reference electrode system. The international consensus is that the standard hydrogen electrode is selected as reference electrodes to measure the value of standard electrode potential. So therefore, we are going to see what is actually the standard hydrogen electrode. In this diagram, the hydrogen gas at 1 atmosphere is flow through platinum wire and platinum electrode coated with platinum oxide into the acid containing 1.0 mole per decimeter cube of hydrogen ions. In this half cell, we will get the standard or E0 value of hydrogen electrode is 0.00 volt. The half equation of hydrogen half cells is 2 hydrogen ions will receive electrons to form hydrogen gas. The standard hydrogen electrode potential, as I said before, is 0.00 volt. This half equation has been modified so that it gets for 1 mole hydrogen ions only. How does scientists determine the standard electrode potentials, or also known as E0? Let's say we want to determine the standard electrode potential value of zinc. This apparatus setup must be used. Okay, The zinc electrode is immersed in a solution that containing 1 mole per decimeter cube of zinc ion solution such as zinc nitrate, zinc sulfate, or maybe zinc chloride. The zinc electrode is connected to the voltmeter, and the voltmeter is connected to the another half cell, which is a standard hydrogen electrode cells. Okay, the hydrogen half cells is connected to the voltmeter using a platinum wire and platinum electrode. These half cells of hydrogen is immersed into a solution that containing 1 mole per decimeter cube of hydrogen ion. These both half cell is connected by salt bridge. The salt bridge contains a saturated solutions of potassium nitrate. What is the functions of salt bridge? You can Google it now, and we can discuss it in our next class. Now, technically or theoretically, what happens to the both half cell we have been discussing before? Noted that the value of voltmeter is 0.76 volt. That means the standard hydrogen potential that we have been discussing just now is 0.00 volt, while the electrode potential of zinc is 0.76 volt. It means that zinc has higher tendency to release electrons than hydrogen. Therefore, hydrogen will become negative terminals, while zinc will become negative terminals. The electrons will flow from zinc electrodes to hydrogen half cells through external circuit, which is connecting wires. From several experiments, scientists have arranged the standard electrode potential value, which is E0, into a standard electrode potential series. These series of half cells are arranged in ascending order of the standard electrode potential value. The series are from the most negative to the most positive of the standard electrode potential, which is E0. This series also known as standard reduction potentials because the half equations are written as reduction reaction, which is in order to receive electrons. Metal ions or molecules receive electrons. E0 value is a measure of the tendency of the substance to accept or donate electron. The half equations of the cells are written as oxidizing agent, receive electrons to produce a reducing agent. This equation can be read reversible. Now, let us familiarize ourselves with standard electrode potential series. Just look at this series. It is arranged from lithium to the manganese ion equation. If we look at the ions in the left side, it is when going down this series, it is easier for the substance to receive electrons, or also said as most or more positive substance. Going down this series, the substance becomes a stronger oxidizing agent. It means that the lower position substance in this series tend to undergoes reduction reaction. But if we look at the right side of the series, which is the metal atoms or sometimes halide ions or hydroxide ions here, and then we can see the chromium ion here. Okay, chromium here, halide, okay, and manganese ion here. This substance on the right side, okay, of that half equation is easier to release electrons. The higher the positions of the substance, it is easier to release electrons and undergoes oxidation. It also said that the substance is more negative. Therefore, it is a stronger reducing agent. Now, look at the E0 value of each substance here. Okay, that is why it is said that the higher position substance is more negative than the lower positions substance. Why does hydrogen E0 value is 0? It is because internationally hydrogen half cells is a standard electrode potential. As a conclusion, let us see the strength as an oxidizing agent and reducing agent of several substances. If the substance is molecules or ions with a more positive E0 value or less negative, the substance, molecules or ions are greater tendency to accept electron. It is easier for the molecules or the ion also to undergo reduction reaction. Therefore, the molecules or the ions is a stronger oxidizing agent. These molecules or ions, I believe, situated at the bottom of the series. While if the atoms or ions with a more negative or less positive standard electrode potential or E0 value, this substance has a greater tendency to release electrons and undergoes oxidation reaction. This substance is a stronger reducing agent. I believe the atoms or ions with this properties situated above in the standard electrode potential series. Now, let us look at the first example of this reaction. This experiment consists of copper wire that is immersed in the silver nitrate solution. Does a reaction occur between copper and silver nitrate? Now we have to refer to the standard electrode potential value. If we look at the SEP series, the value of E0 for copper is plus 0.34, while E0 value for silver is plus 0.80. It is obviously that the E0 value of silver is more positive than the E0 of copper. So basically, we know that copper has higher tendency to release electrons and is a better reducing agent, while the silver ions on the left side is easier to receive electrons, which is also known as more positive substance, then the silver ions also is a stronger oxidizing agent. Thus, our predictions is correct. Now, let us discuss it together. I include here the standard electrode potential value for copper and for silver. E0 value of copper is said to be more negative than silver. Therefore, copper atom has higher ability to release electrons to form copper ion. Copper is a stronger reducing agent, therefore copper undergoes oxidation reaction. But on the other hand, the E0 value of silver is more positive than copper. Therefore, silver ion has higher ability to receive electrons to form silver atom. Silver ion is a stronger oxidizing agent. Silver ion undergoes reduction reactions. Does the reaction occur between copper and silver nitrate? Yes. The displacement reaction occurs. Therefore, we can write the chemical equation for these reactions. Now look at example number 2. This experiment involved a copper wire in magnesium nitrate solution. Does a reaction between copper and magnesium nitrate take place? Remember, we have to refer to our standard electrode potential series first. Look at this series. The E0 value of magnesium is more negative than the E0 value of copper. If we see the value, it can obviously seen that the E0 value of magnesium is negative 2.38, while the E0 value of copper is plus 0.34. 4. But in the reactions, there are copper atom and magnesium ions. What happened during this reaction? Now, let us discuss this together. The E0 value of magnesium is negative 2.38, while the E0 value of copper is 0.34. E0 value of copper is more positive than magnesium. Therefore, copper atom has lower ability to release electron to form copper ion. Copper is a weaker reducing agent. Copper cannot undergo oxidation reaction. On the other hand, magnesium, the E0 value of magnesium is more negative than copper. Magnesium ions has lower ability. Why does I mention about magnesium ion? Because in the reactions in the experiment, we are using magnesium nitrate solution. In the magnesium nitrate solution, there are presence of magnesium ion. Okay, so magnesium ion has lower ability to receive electrons to form magnesium atom. Magnesium ion is a weaker oxidizing agent. Therefore, magnesium ion cannot undergo reduction reaction. Does the reaction occur? No. The displacement reaction cannot occur. Now, in order to increase our understanding on the standard electrode potential value, or also known as E0, let us do this activity together. Carry out a think, pair and share activity by discussing the question with your friends whether the following reactions occur or not. We have to refer to the standard electrode potential cell value in the earlier slide. Okay, now let's go to the first question. This question is between dichromate ion reacts with hydrogen ion comes from acid and chloride ion. We have to identify whether these substances react to produce chromium ion, chlorine molecules, and 7 moles of water. If we look at the standard electrode potential series here, the dichromate ions E0 value is 1 plus 1.33, while the E0 value for chlorine is plus 1.36. We have to bear in mind that for the left side substance, okay, going down the series, it is easier for the substance to accept electrons and undergoes reduction. Therefore, it is a stronger oxidizing agent. On the other hand, for the substance on the right side, going up to the top substance in this series, we know that it is easier for the substance to release electron. Okay, if the substance release electrons, it will undergo oxidation. Therefore, it is a stronger reducing agent. Now, let us refer to this question. We know that dichromate ion Cr2O7 2- ion is less positive, less positive than chlorine molecule. Therefore, it is harder for this ion to accept electron. It cannot undergoes reduction. Therefore, dichromate ion is a weaker oxidizing agent. But if we look at the chloride ion is less negative than dichromate ion. Therefore, it is harder for chloride ion to release electron and undergoes oxidation. That means oxidation cannot occur. Chloride ion is a weaker reducing agent. Okay, therefore, this reaction cannot or doesn't occur. Okay, why? Because if we look here, it is less positive and also less negative. Dichromate is a weaker oxidizing agent, while chloride is a weaker reducing agent. Therefore, the reaction cannot occur. Okay, but if we look at the question number 2, which is B, it is between hydrogen peroxide and bromide ion together with the hydrogen ion that comes from the acid. Again, refer to the series. To the left side, the lower the position, it is a stronger oxidizing agent. it is more positive. It undergoes a reduction and easier for the substance to accept electron. While to the right hand side, or to the right side here, from the low position to the higher position, okay, it is a stronger reducing agent. Bila dia stronger reducing agent, easier for the substance to release electron and undergoes oxidation reaction. This substance is said to be more negative. Okay, this is actually the important or the terminology that must be used when we explaining this question. Okay. Now, refer to the question again. So, kita tengok dulu yang mana ada di sini ialah hydrogen peroxide, okay, and bromide. Okay, sini bromide-nya. Okay, so kita boleh cakap yang pertama, hydrogen peroxide bila dia makin bawah, dia ialah more positive. Okay, bila dia more positive, dia akan ada higher tendency to receive electrons and undergoes reduction reaction. Okay, therefore dia adalah stronger oxidizing agent. Okay, untuk substance yang satu lagi, which is bromide pula, kita tengok kat atas ni, this is bromide, this is the bromide. Okay, bromide ion, dia lebih atas kan, so dia adalah more negative. Bila dia more negative, easier or higher tendency to release electron and undergoes oxidation reaction. Okay, it is said to be a stronger reducing agent. So, can these reactions occur? Therefore, this redox reaction occur. Okay, now, apa beza this question dengan question sebelum ni? Kalau kita tengok question sebelum ni, semuanya less positive, weaker oxidizing agent. Okay, dua-dua less negative, less positive, weaker oxidizing agent, weaker reducing agent. Bila semuanya adalah less and weaker, the reaction cannot occur. But in this question B, the reaction is more positive. Okay, bromide pun more negative. Okay, lepas tu dia juga hydrogen peroxide adalah stronger oxidizing agent, while bromide pula adalah stronger reducing agent. So bila kita dapat results yang macam ni, the explanation, so this redox reaction can occur. Okay, so this is actually a quite hard and challenging question. So I hope with this discussion, I can help you understand this subtopic more. See you in the next subtopic. Thank you very much.